Hello everyone. So in this tutorial I'll be talking about the Vedic multiplier. A lot of people will have seen a lot of calculations on Vedic. It's a very logical way of doing calculation, addition, multiplication and division. But this particular tutorial will be implementing the multiplier only using Verilog. So that is the essence of this tutorial. You can go over to my website projectfpga.com/Vedic. You will see the tutorial. So I actually started with the root, the ground of this tutorial. It starts with the adder, the half adder and the full adder. So I think that's the basic calculating block in digital system, the half adder and the full adder. But I'll just quickly go to the Vedic. So this is the first Vedic here, Vedic multiplier. So but before then you will be able to find the full Verilog files here also. When you go through the tutorial, this is the full Verilog file, but the main Vedic are Vedic 2x2, Vedic 4x4 and Vedic 8x8. The figures represent the bits. That is, if you are multiplying 2 bits, if you are multiplying 4 bits, or you are multiplying 8 bits. So but if you understand how the 2 and 4 works, you'll be able to do 8x8, 16x16, 32x32, 64x64. So they follow basically the same algorithm for them to work. But before you be able to do the Vedic, they have the other block which form the basics of the Vedic. That was why I introduced this tutorial with the half adder and the full adder. So the first files are the half adder, full adder. Then you have the ripple adders, the 4x4, 6x6, 8x8 and 12x12. So the 4x4 is just a combination of 4 full adders. The ripple adder 6 bits is a combination of 6 full adders. The full adder itself is a combination of 2 half adders. The 8-bit ripple adder is a combination of 4-bit ripple adder. The 12-bit is a combination of 2 6-bit ripple adders. So the adders they are more like a subunit of the Vedic. In Logisim, this is what it actually looks like. So I first of all start with the full adder. I think I won't really explain it much how the full adder works. So these are the 2 bits to add. If you're adding only one, you have your sum is 1, carry 0. If you're adding the 2, is you have a 0 and the carry, move it. So that is what the half adder looks like. Then again, so also you have the full adder. This is the full adder. I won't really talk much, but let me just go through the ripple adders to show you what they are. So first of all, the 4x4, this is the 4x4 ripple adder. It's just a combination of 4 full adders make up this 4x4. Then the ripple adder 8-bit is just a combination of the 2. So it's still equally the same as your normal half adder combined up to 8. So but the major interest of this tutorial is the Vedic. So this is the first Vedic here, but I'll be explaining it using this calculation I did on my website. This is the first, the Vedic 2x2 multiplier. So normal arithmetics, if you are multiplying two numbers in decimal, remember the first thing you do is this multiplied with this. Next, B0 multiply with A1. Then another one, you now do B1 multiply with A0, then B1 multiply with A1. So this particular line is just a typical representation of our normal multiplication, A0 and B0, which is this one, B0 and A1, which is this one. On the second line, B1 A0, which is this one, then B1 A1, which is now this one. So, and after that, you will now be able to calculate them. This one comes down, then you add these two together, then you add this, then it will have a carry bit after it. So this is the usual calculation we do when we are trying to multiply two numbers. So in Vedic, this is what is being represented here. This is what is being represented here. So what it entails in Vedic is, first you use a full adder to add these two. After doing, you add A1 B0 and you add A0 B1, then you use a full adder on them. Then you add A0 B0, you add A1 B1. Then these are what will be used as our carry. The output, the carry of A1 B1 will now be used as a carry. So this is how we get all the bits of the 2x2 Vedic. So this Vedic design here, this is the Vedic Logisim, and this is also the representation in Verilog. It skips this part, so it went straight and used it. First of all, did an AND with all of them, A0 B0, A1 B1, A1 B0, A0 B1. So after adding all these values, it now use a full adder to add these two. So once you add these two, this one automatically becomes the LSB of your calculation. If you add these two, it becomes the bit 1. Now this will becomes the bit 2, and then this will become our MSB. So this is basically what the Vedic 2x2 multiplier does. Now to solve this 4x4, after this 4x4, you'll be able to do 8x8. So remember the same method as previously. You use this B0 to multiply everything up here. You now use B1 to multiply everything up here again. B2, use it to multiply everything. Then B2, use it to multiply everything. So that is exactly what I've just demonstrated here. So for this first line, I use B0 to multiply everything up. Then for the second line, I used B1 to multiply everything. Then the next line, I used B2, as you can see. Then for the last line, I used B3. That is for your normal multiplication. Now for the Vedic, this is where I represented the Vedic multiplier here. Now this is what the Vedic did. It actually rearranged this calculation here. So the first thing was that it spotted the Vedic 4x4 spotted 4 different Vedic 2x2. So, and that is how I group them. So watch closely at the grouping. Then let's compare it with, let's just compare it with this one here. We found out how you now see this, and you can spot it here. Then you can spot another one here also. You now spot another one here too. Then finally another one here. So this is how you will be able to spot the Vedic. So there are actually 4 Vedic. So this is the Vedic 4x4. So it first of all used 4 Vedic 2x2 to sort them out, to sort these 4 different Vedics out. Then after that, it now decided to rearrange them. It rearranged them. So first of all, if you solve this, the Vedic in red, you get this. Sorry, you get this. If you solve the Vedic in black, you get this. If you solve the Vedic in green, you get this. And if you sort the Vedic in blue or sky blue, you now get this. So what it did here was to rearrange the four of them. So the four different Vedics were rearranged, keeping in mind that this one is on its own. Azo Bizo will come down. It's part of our final answer. Then this one, we've already summed it up here. Then this one goes like this. So you can see it here also. Watch them down. I substituted the 0 here for the blue. Then here also, you can watch it down. I added a 0 for the blue. Remember here, the blue have no 0. This is the only span of the blue from here down to here. So for particularly here, I'll substitute a 0 there. Then you have here, I'll substitute a 0 for the black. See it here. Then here also, I'll substitute a 0 for the black also. So this is it till the end. So I don't know if you still have any question, you can send me a message directly. So after rearranging them this way, they will now use a ripple, the 4x4, one 4x4 ripple adder and two 6x6 ripple adder. First of all, they added here. When you go through the code, you'll be able to understand how and what exactly they did. They added this 4x4 here. Then they added this to be 6x6. So whatever they got, they brought this one down as an output, brought this one down as output, then used a final 6x6 to sum the output of this one and the output of this one together, and that was how the line here was filled. So it's very easy. If you go through the code, you realize how this rearrangement was actually done. So that is for the 4x4. For the 8x8, it's still the same thing. You will spot 4 different 4x4 Vedics. I've already separated them. This is 1, 2, 3, and 4. So you now start rearranging them and using the ripple adders on them. I've already given the Vero code. They are very short and very easy to understand. So if you combine these two, I think it will be very easy to understand how this Vedic work. Please, thank you.